Hey everybody, Wednesday here, and yesterday we talked about solving equations. So today we're going to move on to solving equations, but with variables on both sides. So similar steps, we're still going to use SADMAP. When it's an equation, we're going to use PEMDAS when it's an expression. First thing I want to do though, let's take a look at a warm-up from yesterday, just how to solve these types of problems. All right, so in this first one, remember that we're kind of working our way backwards. We want to do subtraction or addition first before we do multiplication or division. So we're going to get rid of this 6. Remember that our ultimate goal is to get x by itself. Okay, so this is 2x equals 12. Okay, but we're not quite done yet. Sorry, there goes my dog. Kiara. Shh. Okay, get x by itself, divide by 2, and x is 6. Kiara. No. Okay. Apologize for that. She's clearly doesn't quite know the meaning of not barking at neighbors that walk by. All right, and then second one's pretty tough actually, but we still want to do the same thing. We want to get x by itself, and since this is really, really complicated, but then you have like this random plus 3 over off to the side, we're going to get rid of the plus 3 first, right? Just so it's not on the same side, and we can start working on that thing that looks pretty congested. Okay, so don't forget to do what you do to one side, you do to the other. Okay, and now at this point, you have a couple of options. You can distribute the 1/2 if you want, which I know is probably easier. We could also multiply by the reciprocal since that 1/2 is out front. But let's go ahead and distribute. So 1/2 times 4. So let me change colors here. If we distribute 1/2 times 4, so half of 4 is 2, and half of 8 is 4. So it works out because both numbers are even. Okay, and that equals 18. Now I'm going to go ahead and get rid of the 4 using the additive property of equality. Okay, so now I have 2x equals 22. Okay, now the division property of equality, because it was 2 times x, and x equals 11. Okay, so that's how you go about solving that. All right, so next part is how to solve an equation with variables on both sides. So let's take a look at number 1 here. You can see that we have a negative 4x on this side and we have a 2x on this side. Okay, well, just as we talked about yesterday, imagine this equal sign to be a teeter-totter, right? So if you take away something on one side, you have to also take it away on the other side. Otherwise, that teeter-totter is no longer balanced, right? Like one person, it might even go flying depending upon how much you take off. So if we want to solve for x, we can't have 2 x's just randomly laying around. We have to get them all to one side and get all the constants to the other side. So since these are like terms, but they're on opposite sides, we're going to have to subtract or add them over. And same thing with these constants, okay? So again, it's blocked by this wall. So you could almost imagine it to be, I know this is kind of a math joke, but imagine this blue line down through the equal sign is a wall, and the only way to get across is to use the password, and that password is inverse, right, or opposite. So you can move the x's first if you want. You can move the constants. I'm going to move the constants. Okay, so I'm going to subtract 5 from both sides. So now I have negative 4x on the left and 2x minus 8 on the right. So you can see now all my constants are just on one side. Okay, but I still have my whole number, or my terms with variables on opposite sides. So now I could take the 4x to the right, but then they would all be on the same side again. So instead, I'm going to take this 2x, and I'm going to subtract it because it's positive to the other side. So I now have negative 6x equals negative 8. And from here, I'm going to divide by negative 6. And x equals 4 over 3, or 8 over 6, but 4 over 3 is a simplified version. Okay, so there's our answer for that one. Got to where x is by itself. Okay, so number 2. Okay, similar situation, variables on both sides. Now this one's a little bit harder, or tougher it looks like, because it's just got variables, or I'm sorry, parentheses. But let's go ahead and distribute. Okay, we're going to draw our wall, with the password inverse. Okay, so 6 times negative x is negative 6x. 6 times negative 4 is negative 24. Negative 3 times negative 2 is a positive 6x. And negative 3 times a negative 7 is a positive 21. Okay, we're going to keep going here. All right, so let's go ahead and add 6x to both sides. Okay, and I don't know why I'm adding the 21. Okay, plus 21 down there. All right, so these x's cancel. These ones are still there. Okay, let's get, since this constant's by itself on the left, let's get the other constant over there with him. So minus 21 from both sides. That gives you negative 45 equals 12x. And when you divide by 12, okay, 45 divided by 12, 3.75. Okay. All right. Number 3. Ooh, just getting a little bit tougher and tougher, aren't they? That's okay, though. Number 3. Okay, we could distribute this, and then we're kind of working with fractions, right? The other way that we could think about it is we could get rid of this 1/4 because it's multiplying by dividing, but you wouldn't divide by a fraction. Rather, like we talked about in class, you multiply by the reciprocal. So we're going to multiply this by 4/1, and what you do to one side, you have to do to the other. Okay, so that's going to cancel those fractions on that side. So now I'm just left with 3x minus 5. We can drop the parentheses because there's nothing outside of it anymore. Okay, and then the 4/1, let's just multiply that by the 8, and that gives us 32/1, which is just 32, times 1/2 x plus 1/2. All right, so now at this point, we don't have any choices. We have to distribute that 32 or divide, and then it could get really messy. So 3x minus 5 on the left, and then multiply the 32 through when you use distributive property. Well, half of 32 is 16, and the same thing right there. Okay, so now again, we got to start combining these like terms. So it doesn't matter which way you go, but as long as all the x's are on one side, constants are on the other. So I'm going to subtract 16 from both sides. Again, here's my barrier. That gives me negative 21, and 3x equals 16x, and this cancels. Okay, now I'm going to get the x's to the right-hand side. So since it's positive 3x, I'm going to subtract 3x. Okay, and now I'm going to divide by 13. So this is a weird number. Let's see, 21 divided by 13 is 1.61, etc. So about 1.62. But 1.61 is the golden ratio, by the way. I'll have to show you that one. There's a Daffy Duck thing I can show you guys later. Okay. Next one. Let's go ahead and distribute the 6 because there's no outside the parentheses on the other side. Okay, so we have 1/2 y minus 2 equals 1/3 of 6. So what is 6 divided by 3? 6 divided by 3 is 2. And 1/3 of 6 again is 2. You can put that in your calculator. So 1/3, 1 divided by 3 times 6. That's how you'd put that in if you needed to. All right, let's go ahead and add 2 to the other side. My barrier. So 1/2 y equals 2y plus 4 now. Okay, we're going to subtract the 2y from both sides. Okay, so if I have 2 pieces of pizza and I eat just a half of one, how much is left? Well, 1 1/2, right? Or 3/2. Y, and this would be negative, equals 4. Okay, just like yesterday, we have a fraction out front. We're going to multiply by the reciprocal. So negative 2/3 multiplied by negative 2/3. So y equals, this cancels out. This is over top of 1. 4 times negative 2 is negative 8. 3 times 1 is 3. Okay, and I'm good with that. You can just leave it there. You don't have to calculate that. Okay, so error analysis here. In each of the following problems, identify where the mistake was made, if there was one, correct it, and solve the equation. Okay, so in this first example, I'll give you a second. Here's where I want you to go ahead and pause it, and I want you to look through it and see if you can figure out where did they make a mistake. Okay, hopefully you actually paused it and went through that, but as you can see, there were actually two mistakes here. So first of all, they said a +4 when this was already a +4. So we're using inverse operations. Secondly, 2 divided by 2 is not 6, right? So that's the mistake there. So there's actually two mistakes, so let's go ahead and correct it off to the side here. So this would be -4 on both sides. So -4 on both sides. That would cancel the 4's. Negative 2x equals negative 6. Divide by negative 2, and x equals, oh, and I almost forgot, they actually had 3 mistakes on this one because they left this one as positive. It should have been negative. So that would be negative 6 divided by negative 2 is positive 3. Okay. All right, number 2. Let's see. Distributed first. Good. 5 times 1 is 5. Okay, 5 times 4 is 20h. Well, 4h is 20h. 2h left over, 27. Okay, this line looks good. All right, 20h plus 2h is 22h. Oh, there it is. There's our mistake. They just combined everything, but 5 does not have an h with it. Okay, so it would be right there. So this should actually say 22h plus 5 equals 27. Okay, now we're going to subtract 5. Subtract 5. 22h equals 22. Divide by 22. H equals 1. Okay, so ironically got the same answer, but they did not do it the correct way. Okay, number 3. Again, pause it if you can. Okay, so mistake was right here, negative 2. Since this was already positive or negative 2 up top, this should have been plus 2, right? Which would make this 16, which would make this 8. 16 divided by 2 is 8. Okay. Number 4, 5y plus a negative 5 equals 10. Answer is right here. Okay, since you're adding a negative 5, in order to do the inverse of that, this would have to be positive 5, which would make this 15, which would make this 3. Okay? All right, so I want you to do the same thing on these on the exit ticket. There are 4 questions. It is error analysis, so your goal is to identify the error and then rework the problem. So basically in this column here, you're going to identify, okay, what did they do wrong? Whether they didn't add right or maybe they didn't subtract right. So you're going to identify here. And then in this box, you're actually going to work out the problem. So the beginning of the problem is up here at the top. Okay, and you're just trying to solve for the variable. So in this one, you're trying to solve for C. This one, you're trying to solve for X, and M. If you have any questions, let me know. You can also look in the iBook. This is section 1.5 in the iBook, so Unit 1, Section 5. And there are some other examples in there as well. All right, you guys, have a great day.